Okay, so now we're going to add dipoles if necessary. And to do that, we need to look up the electronegativity of these two atoms and compare them. So let's look it up. What's lithium's number? 1.0? Okay, so we have 1.0, and then what's bromine? 2 point what? I think it's 2.8. Yeah, it's hard to read. 2.8. Okay, and what's the difference between those two? 1.8, right? Okay. So, do you remember what the range was for polar? What was it? 0.4. Okay. So, what I like to do is I like to have a little kind of range chart over here that'll show me the different categories. Okay, so here we have 0 to 0.3. That was non-polar. All right, 0.4 to 1.9 is polar. And we didn't really talk about this, but anything above 1.9, anything in the 2 or higher, that's going to be ionic. That means that it pulls the electrons so much that it rips it off. All right, and that's why it's ionic. Polar means there's uneven pulling, so it's pulling it a little bit. That's going to make it slightly negative, slightly positive. And this they're going to share pretty evenly, so that's going to keep it neutral. All right, so this little chart will help us with this. All right, and then as you said, you subtracted these two, you got 1.8, and that's in here, so that's good. It's going to potentially be polar. And I say potentially because it depends on the shape as well. Now, luckily, this is just kind of like a little line here, so it's going to be polar just because there's not a lot of differences in the shape. But let's check it out. Which way do I draw the arrow? Yeah, towards the bromine. All right, so we're drawing it towards the bromine from the lithium because that's where the electrons are going to hang out. They're going to hang out by the bromine. You said it was 1.8. All right, so it's going over there. All right. And then how do I actually distinguish that it is polar? What do I need to add to it? Yeah, the lowercase deltas. I'm just going to draw it again here just so it looks nice. All right, so the lowercase deltas. Which one's going to be negative? The bromine, yeah, exactly. So this one will be slightly negative. This one will be slightly positive, right? All right, so we'll get those. And that's pretty much all you'd have to show. All right. There's another way to show this that you may see later on with this whole arrow and whatnot. Instead of putting the slightly negative and slightly positive, sometimes they do this. They put this tail here like a little plus sign showing that this is the positive side, and then the arrow is going towards the negative side. So that's okay as well. I'd prefer that for this year you use the lowercase deltas just so we're all doing the same thing. But next year in AP you may see this as well. All right. Now moving on from this problem, I want us to talk about dipoles real quick. If I wanted to draw another molecule of lithium bromide over here, what would I draw closest to the bromine? Lithium. Okay, why would I draw the lithium? Yeah, it's going to be slightly positive, right? All right, so let me draw this out. Lithium's slightly positive. Bromine's going to be slightly negative. Good. Okay. And tell me more about this. What can we say? Hydrogen bond, right? Oh, but look at this. There's no hydrogen. No hydrogen, but that's okay. It's the same thing. This is a dipole-dipole interaction. You'd still show with the little dots there that there's an attraction between those two, all right? Between those there. And that negative and that positive are attracted to each other. So even though there's no hydrogen, don't think that you can't have attraction between two molecules. If it's slightly negative and slightly positive, it can happen, all right? Any other questions with that? Another interesting thing about this was in the beginning of the year, we said everything to the left of the staircase on the periodic table and everything to the right, if you mix those two things, it's going to be ionic because one's a metal and one's a non-metal. This shows us that that's not always true because this is a metal, this is a non-metal, but they actually will form this polar covalent bond here. So we need to check the electronegativities to make sure that it is polar or ionic, all right? A simplified version of it is just thinking that when you have a metal and a non-metal, it'll always be ionic, all right? But now that we've learned this, we'll have to use this in the future, okay? Any other questions with that one?